How to troubleshoot amplifier designs effectively. Imagine turning on your audio system or radio and hearing distorted sound or no sound at all. Troubleshooting amplifier designs can seem tricky, but with a clear plan, you can find the problem fast. First, understand what type of amplifier you are working with. Is it a common emitter bipolar junction transistor amplifier, an operational amplifier, or a Class E radio frequency amplifier? Knowing the design helps you know what to check first. Look at the amplifier's specifications, like gain, bandwidth, and power supply needs. These details tell you what normal operation looks like and guide your troubleshooting. Next, check the power supply and biasing. Make sure all power supplies are connected correctly and providing the right voltage levels. Use a multimeter to measure direct current bias voltages at key points, such as the base, emitter, and collector of transistors, or the gate and drain of field effect transistors. If these voltages are off, the amplifier may not work properly or could distort signals. For example, in a bipolar junction transistor amplifier, the bias point must be stable to keep the amplifier linear. Then, verify all component values and connections. Resistors, capacitors, inductors, and active devices should match the schematic. Resistor values that are too high or low can change the gain or bias point. Capacitors with incorrect values can affect the frequency response. Check for any faulty or reversed components, as these often cause malfunction or distortion. Use signal injection to trace the problem. Feed a known test signal into the input and watch how it moves through the stages with an oscilloscope. Look at the waveforms at each point. If the signal is distorted or missing at a certain stage, that's where the fault lies. For example, if the output waveform looks like half a sine wave, it might mean one transistor in a push-pull stage is not functioning. Be alert for oscillations or stability issues. Sometimes amplifiers produce high-frequency oscillations that cause noise or distortion. Use the oscilloscope to check for unwanted signals on the output or power lines. Improving decoupling with better filtering or adding negative feedback can help stabilize the amplifier. Measure the frequency response and gain. Use a signal generator to test how the amplifier performs across its frequency range. If the gain drops unexpectedly or the bandwidth is limited, it could be due to aging components or layout issues. Adjusting resistor values or adding feedback can improve linearity and gain control. Check the physical condition of the amplifier. Overheated components or loose solder joints can cause intermittent faults. Feel for hot spots and inspect solder connections carefully. Good thermal management and solid mechanical connections keep the amplifier working reliably. Compare your measurements with simulations or reference designs. Simulations can show you what to expect and help identify discrepancies. If your real-world results differ from the model, it points to a component fault or layout problem. For specific amplifier types, there are special considerations. For Class E radio frequency amplifiers, verify that the operating frequency matches the component resonant frequencies. Unusual DC offsets or amplitude issues at certain frequencies may indicate bias or component mismatches. For operational amplifiers, ensure the power supplies are clean and stable, and that you have proper bypass capacitors to prevent parasitic oscillations. Troubleshooting is about being methodical. Check power and bias first, then verify components, trace signals, and look for stability issues. Using these steps, you can quickly identify faults and restore your amplifier to proper working order.